Okay, this video will show how to solve for the solutions that exist for a standard form system of equations. We'll write the problem down and then we'll start to solve. So the problem that we're given, let me write it here in the top left. The problem that we're given is 2x minus 4 equals 0. And then we're also given 7y plus 49 equals 0. Now, these equations aren't really in standard form, because if they were, these values would be over here on the right side of the equal sign, the numbers that are by themselves. But we can still solve this. So what is our path forward here? This is a bit of a tricky problem, because there's really not a y value in this first equation, and there's not an x value in this second equation. So let's do what we can with this problem and see, because we're calling this a system of equations. So there's more than one equation, it's a system. So here's our system of equations right here. Okay. All right. So now that we have our system, we'll see what we can do to solve for it. Let's take the first equation right here. We have 2x minus 4 equals 0. All right. So we'll isolate the x variable by itself by adding 4 to both sides. Right? Which cancels out these terms here, because negative 4 plus 4 is 0. And what we're left with is 2x equals 4. If 2x equals 4, then we just divide out the 2 on both sides of the equation. The 2's cancel on the left, leaving x equals 4 over 2, which can be reduced to just 2. X equals 2. Alright, so x equals 2. Now we'll do the same thing for the y down here. We'll solve for y. So we're given 7y plus 49 equals 0. Now, what I'll do is subtract out the 49 on both sides. And this cancels. We're left with 7y equals negative 49. Well, now what? Okay. Well, now we divide both sides by 7. The 7's on the left cancel, leaving y by itself. And y equals negative 49 divided by 7. Now, 7 goes into 49 7 times, so you end up with negative 49 divided by 7 is just negative 7. So y equals negative 7. This is an interesting problem, because we've actually solved for these two variables all by themselves, and if we were to graph them, we would see the intersection point. Right? So let's graph this. Now we can graph x equals 2 first if we want. well, let's make some marks. We'll call this 1, 2, 3, 4. Okay, and then on the other axis, this is -1, -2, -3, -4, -5, -6, -7. So that's going to be -7 right there, and this will be 2 right here. Okay, so x equals 2. All right. Remember, when you have just x by itself and you're going to graph it, it's a perfectly vertical line. The slope is undefined. So here's your line. This is line x equals 2. Now let's graph we'll use red pen to graph the y value. Y equals -7. So let's just graph this here. Right at -7, the slope is 0, so you draw a perfectly horizontal line right here. And this line is labeled y equals -7. Well, this point right here is the solution to the system of linear equations. And that solution is actually a coordinate. So what are the coordinates? Well, x equals 2 and y equals -7. So the solution to this system of linear equations is 2, -7. This is what you're looking for. There's your solution to the system. These two lines form a 90-degree angle right here. They're perpendicular to one another. Right now, we didn't need to use substitution in that example. Let's see if we can find a problem where we have to use substitution to solve, because that was kind of the skill we were working on. Okay, we will get a new page here. And here is, we're going to be asked how many solutions exist for the following system. So the question is, how many solutions exist and what are they? And the equations that we're given are y equals 3 over 2x plus 5. And then we were also given 2y over 3 minus 5 equals x. Okay, so notice that our first equation in our system, again this is the system, our first equation is already in slope-intercept form, so we can just leave that just like it is. And what we'll endeavor to do with this second equation is manipulate the numbers around until we have this in slope-intercept form, and then we can just set it equal to each other. So what I want is I want y by itself here. So we'll just take this second equation, start moving things around. I'm given 2y over 3 minus 5 equals x. And I remember I want to solve for y. So let's start working on this. The very first thing I can do is multiply out the 3. Now let me show you what we do here. So I'm going to multiply the entire left and the entire right side by 3 over 1. Okay, so we can actually do this problem without applying any kind of quick tricks. Let's go ahead and distribute multiply this, and we'll leave the number 3 by itself. So when I distribute multiply this 3, I'm going to multiply it here and here. All right, so I have 3 times 2y divided by 3 minus 3 times 5. Okay, that's going to be in parentheses. Equals, now we have to multiply 3 over 1 times x, and I end up with 3x. Now, are we done? No. These 3's can cancel. Okay, so they go away. What's left is 2y minus, and what's 3 times 5? 3 times 5 is 15, so minus 15 equals 3x. Well, now what? Now it's just a matter of getting y by itself. So I'm going to move out this 15. Okay, negative 15 plus 15 is 0, so that just cancels out. And we're left with 2y equals 3x plus 15. Now divide out the 2 on both sides. Remember, when I divide out a number on the left, I have to divide the entire right side by that number. So I'll divide by 2. And now I have y equals 3x plus 15 divided by 2. And before I rewrite that, let's notice that this 2 has this huge denominator bar above it, which means that both terms separated by the plus sign can have that denominator. So I could actually write this y equals 3 over 2 x plus 15 over 2. Okay, now that's actually the solution. We could divide 15 by 2 and say 7.5, or we could just leave it as a fraction. We always want to leave this as a fraction because this is helpful. This is our slope. So if I was going to graph this line, which I am, I'm going to graph 3 over 2 because that's rise 3, run 2. So if I wanted to, I could say, just to finish this problem off, y equals 3 over 2 x plus 7.5, if that makes it a little bit more clear. Okay, so let's go back up here and put in our new solution here. This is kind of rewritten. This whole equation here can be rewritten. Y equals 3 over 2x plus, now remember I wrote 7.5, but I could also write 15 over 2. It's the same thing. I'm going to write 15 over 2. You'll see why here in a bit. Okay, now it's time to perform this substitution game. The way we do that is we see that y is equal to 3 halves x plus 5, and that same y is equal to 3 halves x plus 15 over 2. If I was going to continue I would find, and I will continue this to show, just in case you don't see it yet, but there's something wrong that should cause us to stop. Say, how many solutions and what are they for this system of equations? Notice that we have a slope value here for y and a slope value here for y. In both of these equations, these slopes are identical. So remember, identical slopes indicate parallel line. Okay, so let's draw parallel lines here real quick. Okay, here's some parallel lines. My question is, are these lines ever going to cross? No. So since these lines will never cross, this indicates there are no solutions to this system. No solutions. So you could stop right there. If you were to graph these two lines, you would never find a point where they intersect, right? One of them just has a y-intercept of 5 and the other one has a y-intercept of 7.5. If I put them equal to one another, you'll see that you come up with gibberish, and I'm going to do that. It's not necessary. You could stop right here, right? Look, same slope means there's no solutions to the system. So we call this an inconsistent system. This is inconsistent. But let's try to do the math, and you'll see how it doesn't work. I now have 3 over 2 x plus 5 equals, so I'm taking this equation here, or this expression, setting it equal to this expression right here, equals 3 over 2 x plus 15 over 2. If you try to solve this, you'll come up with nonsense answers. So let's do that. All right, we're trying to get x by itself. So what we'll do is we will say minus 5. Okay, and then we have 3 over 2 x equals 3 over 2 x plus 15 over 2. And now let's put 5 in terms of 2. We'll say minus 10 over 2, because 10 divided by 2 is 5. Okay, so I can do this. 15 minus 10, I come up with 5 over 2. So now I have 3 over 2 x equals 3 over 2 x plus 5 over 2. Okay, so now here comes the point where you're going to have a problem if you don't already see it. I now want to get x by itself, right? So I'm going to subtract 3 over 2x on both sides. Okay, these cancel out. Uh-oh, these cancel out as well. Look, 3 over 2x minus 3 over 2x. I get 0 for both of these. So these, again, these cancel out. That's not going to work because now I have 0 equals 5 over 2. And that doesn't work. 0 does not equal 5 over 2. So again, there's another way of confirming no solution. Okay. All right. Let's try another problem, see if we find one where we actually have a system that solves out to a single value. Let's take another example, and this example asks us what values of x and y make the system true. It's kind of a strange way of wording it, but that's how it is on the standardized exams. They're always asking what value makes something true, and it's kind of confusing even to me to read it like that, but that's what you're given. So here's your first equation: x plus 4y equals 72. And your second equation is negative y equals negative 3x. Okay, so this is my system again. And I'll just need to get both of these in y equals form. So I'll take the first equation, x plus 4y equals 72. So solve for y here. Subtract out x on both sides. These cancel, leaving 4y equals negative x plus 72. I can't combine x and 72, I just have to write them out. Then I divide both sides by 4 to get rid of the 4 on the y side. The 4's cancel on the left, leaving y by itself. Now I have this fraction again. Remember, I can split these values up, and we'll go ahead and put the intermediate step in here. I now have negative x over 4 plus 72 over 4. Well, is there any way I can rewrite this to be a little bit more clear? Sure. Negative x over 4 is the same thing as negative 1/4 times x. So I can rewrite this: y equals negative 1/4 x plus, and now what's 72 divided by 4? And let's say you didn't know it in your head and you didn't have a calculator handy. A quick little 72 divided by 4, how many times does 4 go into 7? One time. 1 times 4 is 4. Okay, we're left with 3, 2. Bring the 2 down. How many times does 4 go into 32? 8. 8 times 4 is 32. No remainder. Okay, so it's 18. I divide 72 by 4, I get 18, so I write negative y equals negative 1/4 x plus 18. Right, so now I've solved this first equation in slope-intercept form. So before I continue, I'll go ahead and write that in. Now it's time to work with this guy here. Now this is actually quite easy because we want y by itself, right? We have negative y equals negative 3x. Remember, I can just plus these minus signs out. It's essentially like multiplying or dividing both sides by negative 1, because this is really negative 1y. If I divide both sides by negative 1, I'll get, well, I'll get 3x on the right. I guess I should show it. Here's my second equation. Negative y equals negative 3x. Okay, so to reimagine this as negative 1 times y equals negative 3 times x. Right, so if I want to get y by itself, I have to divide both sides by negative 1. And what that leaves me is these negative 1's cancel, and I'm left with y equals negative 3x divided by negative 1. Okay, now these negative signs will cancel because a negative divided by a negative is a positive, which leaves me just 3x. We don't have to write 3x over 1. It's just convention. We don't have to write it. So to rewrite this up here, we have y equals 3x. You say, well, where's it's supposed to be in slope-intercept form. Where's the b factor? Well, it's just 0. So this is assumed to be plus 0 here. We don't write it, but really this is what the expression's saying. It's 3x plus 0. We just don't write it by convention. So now we're going to perform the substitution here. So what we'll do is set these two equations equal to one another. Right? So let's just do that. Negative 1/4 x plus 18 equals 3x. Okay, so in order for me to get x by itself, I need to get all the x values over here on the left or the right. It really doesn't matter. I'll put it on the left, and then we'll move this other value to the right. So here's what we're going to do first. First, we'll move this 18 to the right side, just because people are more comfortable seeing the x on the left. It really doesn't matter. So now I have, this cancels out, I have negative 1/4 x equals 3x minus 18. Okay, well, what I want to do now is get this x value over here on the left. So I'll subtract out 3x on both sides. Okay, on the right side the 3x's cancel out, and on the left side I have negative 3x minus 1/4x equals negative 18. In order to proceed, we have to get 3 in terms of 4. Now when I say that, what I mean is we need a value of 4 in the denominator, and we need the numerator to be such that when I divide the numerator by the denominator I get negative 3. So here's what I need. I need a number which when divided by 4 gives me negative 3. What number gives me negative 3 when I divide it by 4? How about negative 12? So I could rewrite negative 3 as negative 12 over 4 x minus 1 over 4 x equals negative 18. Now, when I have two negative numbers and I subtract them, the numbers get bigger. Okay, the absolute value of the numbers get bigger. So I have negative 12 minus 1. That means I'm going to end up with negative 13. Okay, so I have negative 13 over 4 x equals negative 18. Okay, so I want x by itself. Remember that. So in order to get x by itself, I need to multiply both the left and the right by the reciprocal of this fraction here, negative 13/4. So I'll multiply by 4 over negative 13 and 4 over negative 13. Okay, now just taking a look at this, these 4's cancel out and this negative 13 cancels out, leaving x by itself. X equals negative 18 times 4 divided by negative 13. Okay, well, what is 18 times 4? I need negative 18 times 4. So we'll do that math over here. 18 times 4. If you don't remember it from before, it's 8 times 4 is 2, carry the 3, because 8 times 4 is 32. I have 4 times 1 is 4, plus 3 is 7. 18 times 4 is 72, but remember it was negative 18 times 4, so I have negative 72. Okay, so we'll go down here. We have x equals negative 72 over negative 13. Okay, so negative divided by a negative gives a positive. I have x equals 72 over 13, and that's my x value. All right, in order to find the corresponding y value, all I need to do is plug this x value back in to one of my equations, and that's substitution. Okay, so I'll plug this x value, 72/13, back into one of my equations, and it doesn't matter which one. We'll do it for both equations just to prove the point, but it doesn't matter which one. So we're going to substitute 72/13 back into our equations. We'll take this one because look, all I've got to do here is multiply 3 times 72 over 13. That should be easier than multiplying 72/13 by negative 1 over 4 and then adding 18 to it. That looks complicated. So go over here and plug in y equals 3x. So I'm going to substitute 72 over 13 for x. So I have y equals 3 times 72 over 13. So what is 3 times 72? Oh, okay, 72 times 3. 2 times 3 is 6. 7 times 3 is 21. That gives me 216 over 13. Y equals 216 over 13. Okay, so the question is there any way to reduce that value? Let's see if there's any common factors. If we didn't know, we could see by taking 216 and make our little tree. And really this is another way of showing this that might be helpful is to take 216 here, take 216 and then do this upside down division. Okay, and we're going to divide 216 by 2. So 2 goes into 2 one time. Okay, 1 times 2 is 2. Okay, bring down the 1. 2 goes into 1 0 times, and then we bring down the 6. So how many times does 2 go into 6? 3 times. I think I did that wrong. So 2 goes into 2 one time. I don't like this upside down division. Let me rewrite this. This is confusing to me. Okay, 2 goes into 2 one time. 2 times 2 is 2. Okay, so 0, bring down the 1. 2 goes into 1 0 times. 0 times 2 is 0. Okay, and then we bring down the 1 and the 6. 2 goes into 16 8 times. Okay, yeah. So I have 108, 108. So my first tree is 2 and 108. So I can still divide 108 by 2. 108 divided by 2 gives me 2 goes into 10 5 times, and 2 goes into 8 4 times. So I now have 2 times 54. Remember, 13 is a prime number, so what I'm looking for is another 13. Well, 54 divided by 2, two goes into 5 twice, that's 4. 14, 2 goes into 14 7 times. So I now have 2 times 27. Now I can't continue dividing 27 by 2 because it won't divide evenly, so I have to divide 27 by 3. 27 divided by 3, that's 3 times 9, and then 9 can be factored into 3's. So I have 2's and 3's. I don't have any 13's. There was no common number between 216 and 13. So that is what that indicates to me, is that this is in the most reduced state that it could be in. This is the prime factorization of 216. Okay. So that means that's our y value, and our x value was 72 over 13. So we can write x equals 72 over 13 right here. So if we're looking what values of x and y make the system true, well, these values make the system true right here. Okay, but we typically don't write it like that. I mean, you could, but the way that I would write it is as a coordinate pair, 72 thirteenths for x, comma, 216 thirteenths for y. So these values make the system true. Okay. So if we're just continuing with this system of equations type problems, we can actually play a little game with our calculator. Here, second quit, second plus 7 1 2, clear the memory, and I want to go into math. Maybe that's not where I want to go. Apps rand int was what I'm looking for. I'm looking for rand int. Where did I get that before? Stat. No. Where was I getting that before? Math. There we go. Okay, so if you hit math and you go under probability, You can generate random integers by hitting 5. You got to set limits on this. So we'll set a limit of -10 on the lower end and 10 on the upper end, and enter, enter, enter. So here's a random integer, 9. So we'll record that 9x. We're making up a problem here. So now I'll go find another random integer. Just hope it's not going to give me the same one every time. Okay. 9x minus 7y equals, go back up and find another random integer. Okay, 0 is boring, so we'll find another one. -2. And then we'll do this again. 5x minus 10y equals -3. Okay, so we'll solve this system of equations, this randomly generated system of equations here, and see how many solutions we get and what they are. So here is our system. These two equations are given in standard form, so just like previously, my first step is to get these equations in slope-intercept form. 9x minus 7y equals -2. Okay, so first I'll subtract out 9x on both sides, and I have -7y equals -9x minus 2. Divide out the -7 on both sides, and I have y, these cancel, y equals -9 over 7, -9 over -7x minus 2 over -7, which can be rewritten y equals 9/7 x plus 2/7. Okay, that's our first equation rewritten. Y equals 9/7 x plus 2/7. So now we'll find the slope-intercept form of this equation right here. Okay, so 5x minus 10y equals -3. And we subtract out 5x on both sides. We have -10y equals -5x minus 3. Divide both the left and the right by -10. We have these canceling out on the left. We're left with y equals, remember we can split up this denominator, y equals -5 over -10x minus 3 over -10, which you can no longer see. Okay, so I can rewrite this because these negatives are going to cancel out. Y equals, what's 5 divided by 10? That's 1 over 2, positive 1 over 2, x plus 3 over 10 and that 1/2 x plus 3/10 is the rewritten form of the second equation. So y equals 1/2 x plus 3 over 10. The substitution here will be to set these two expressions, 9/7 x plus 2/7 equal to 1/2 x plus 3/10. So we'll do that here. Make a little space to do that. We'll set 9/7x plus 2/7 equal to 1/2x plus 3/10. Okay, remember our goal here, even though these are complex looking, scary looking fractions, our goal is to get x by itself right now. So what I'll do is subtract out 2/7 on both sides, and I'll have 9/7x equal to 1/2 x plus 3/10 minus 2/7. Okay, so I need to subtract 2/7 from 3/10. In order to do that, I have to find a common denominator between 10 and 7. The only one that I'm aware of is 70. So I need to multiply this value right here times 7/7, and I need to multiply this value right here times 10/10. You know, don't confuse these with exponents. It's just a notation style that's probably confusing when it doesn't need to be. Let's see here. So now I've got 9/7x equals 1/2x. Now I'm going to multiply 3 times 7 and 10 times 7. I'll have plus 21/70 minus 2 times 10, 20/70. The whole point was to get a common denominator, and I have one, 70 and 70. So now I have, just keep rewriting, 9/7x equals 1/2x. Now I have 21 minus 20/70. That gives me plus 1/70. Right? So now I just, to get x by itself, I'll subtract 1/2 x from both sides. And what I'll write is 9/7x minus 1/2x equals 1/70. Similar to what we were doing before, I have to find a common denominator between these x coefficients. Well, the lowest one that I'm aware of is 14. So again, we have to multiply the 7th coefficient by 2/2, and we have to multiply the -1/2 coefficient by 7/7. And then what I'll end up with is 18/14. Can't see it. 18/14 x minus 7/14 x equals 1/70. So now that we have common denominators for our x coefficients, we can just subtract 7 from 18. So 18 minus 7 is 11. So that leaves me with 11/14 x equals 1/70. Okay, so now in order to get x by itself, I have to multiply both sides by the reciprocal of the coefficient here. So I'll multiply both sides by 14/11. these cancel on the left side, leaving x by itself. So now x equals 1 times 14 is 14 over 70 times 11. Well, what is that? 70 times 11. 7 times 11 is 77. So 70 times 11 should be 770. But if you're not sure, you don't feel like doing the relevant multiplication, well, we've kind of been doing that though, haven't we? So we'll just do it. We'll go ahead and do this multiplication. 70 multiplied by 11 by hand. So 0 times 1 is 0, 7 times 1 is 70, 0 times 1 is 0, 7 times 1 is 70. Or 7. So if I now stack add, I have 0, 7, and 7. So 770. So what I'm saying is 70 times 11 is 770. So x, the x component of our xy solution for this system, is 14 over 770. Okay, so that's good to know. Now we just need to plug this value into one of our equations. It doesn't matter which one. They should both evaluate out to the same thing. So I could kind of say, introduce a new notation here. F of 14 over 770 and F of 14 over 770. Both these equations should solve to the same y value. I'm just putting it in functional notation because what we're going to do is plug in 14/770ths in for x. So I'll say, well, this is 9 over 7 multiplied by 14 over 770 plus 2/7. Okay, this gets done first. Now, on the bottom equation, I have 1/2 multiplied by 14 over 770 plus 3/10. Well, it's kind of time to work it out, isn't it? I need to multiply 9 times 14 to get the numerator here. What is 9 times 14? Again, if I don't know, there's an easy way to find out. Let's take a piece of scratch paper now because I'm going to run out of space. 14 times 9, it's 36. Carry the 3. 9 times 1 is 9, plus 3 is 12. So that's 126. Okay, so, and then 7 times 770. We have 0 here, 9, 4, 49, 50, 51, 52, 53, 5390. So I'm left with my fraction 9/7 times 14 over 770 is equal to 126 over 5390. Okay, that's what I'm going to put there, plus 2/7. Plus 2/7. Well, I need a common denominator between 5390 and 7. There might be a common denominator that is 7 times 5390. 7 is a prime number, so there's no lower common denominator. I'll multiply 7 times 5390. Okay, so I get 5390 times 7, 063. 3 times 7 is 21, plus 6 is 27. And then 7 times 5 is 35, 36, 37. So now I have 37,730 as my common denominator. All right. So what that means is I'm going to multiply this by 7 over 7 and this by 5390 over 5390. And what I get is, let's do some more multiplication here. What I get is 126 times 7. 6 times 7 is 42. 2 times 7 is 14, carry the 4. With the 4 I've got 18. 7 times 1 is 7, plus 1 is 8. So that's 882. This is 882 over 37,730 plus, okay, so now I've got to multiply 5,390 by 2 and 7 times 5,390. Let's go over here and say 5,390 times 2. What is that? Well, 0, 18, 6, 7, and then 15 or 10. So I've got 10,780. Okay, and then I got to do 5390 times 7. Oh, and I already did that. Okay, so that's 37,730. All right, so my new common denominator fractions are 10780 over 37,730. Okay, so I'm going to add these two things together. Okay, so the question is, what is, I've got a common denominator, what is 10,780 plus 882? Well, 0 plus 2, what is that? 2. 8 plus 8 is 16, carry the 1. 7 plus 8 is 15, carry plus 1 is 16. Carry the 1, 0 plus 1 is 1, 1 plus 0 is 1. So I have 11,662 over 37,730. Okay, that is what this equals. This equals 11,662 over 37,730. Well, the question is, does that equal this? Well, let's see. So here I've got 1/2 multiplied by 14 over 770 Okay, so I have to find that these multiply out to be 14 over, and then we already did 770 times 7. I guess we have to do it times 2 this time. 770 times 2 is equal to 0, and it's 14. 14 plus 15, so 1,540. 1,540. All right. And then we add to that plus 3 over 10. All right, so in order to do this problem, we need to multiply this times 10 over 10, and this times 1,540 over 1,540. There might be a, might be able to do something else there, but let's just do it this way because I know it'll work. We'll say that 14 times 10 is 140, and then, oops, I bumped that. Then 1540 times 10 is 15,400. Okay, plus 3 times 1540, so we have to do that little intermediate computation. 1540 times 3, 0, 2, 1, okay, 15, 16, 46, 20. So I have 46, 20 over 15,400. Okay, so now to add these two things together, I have to add 4620 to 140. So I'm just going to add those two, 0, 6, 7, and 4. So now my answer is 4,760 divided by 15,400. So that's what I found here. Now these should equal one another unless I've made some stupid computation error. We'll say 11662 divided by 37730. Okay, that gives that extremely small decimal, 0.3. Now let's see if it's going to equal 4,760 divided by 15,400 gives the same decimal. Do you see that? 0.309. So looks like it's not a rational number, so we'll just say, approximately equal to 0.30909. Okay. And then 0.30909. Okay, so the solution to this system of equations, the solution to this system is, for our x value, we got 14 over 770. And then for our y value, we got this irrational number, and I'll just put it in here as 0.30, and then it's 90 that repeats forever. Like that. So that's the solution to that system of linear equations.